just kind of give you an overview of kind of a broad picture of my kind of understanding of the Foundation Ice Stream-Academy Glacier complex in Antarctica, and some of its history, some of the recent work that people have done on it, and then also maybe kind of starting to think about kind of steering us in some directions as a community about maybe what we should be finding out. And I guess that probably that section's not as well developed as I might have hoped it might have been at this stage, but there's some kind of broad brushed kind of things towards the end. So what I should say as well is I should acknowledge, first of all, a lot of what I'm going to present today is a result of data sets that have been acquired by other people and work that's been done by other people, and hopefully there'll be recognition along the way as we go on this. But I'd like to thank ESA in particular and NASA for some of the data sets that we've kind of looked at over the course of this, over the course of the last few years. Okay, so I've got kind of two motivations really for kind of this seminar, and the first one is kind of you get to a point in your career where you think really should be starting to think about maybe writing a decent review paper, and maybe that's been a result also of kind of developing a dissertation research plan module where students are always looking out for good review papers to kind of start their research off and things like that. So I thought maybe this might be a good place to kind of start. I'm kind of inspired by some of these papers which take a kind of holistic view of kind of Pine Island Glacier and Rockford Ice Stream from the West Antarctic Ice Sheet volume, I think Chapman conference, I think from way back in the early 2000s. So this is kind of my inspiration for why I might think about it. Of course, the thing is I haven't actually written this review paper yet, but maybe it's on the cards in the next few years. But the other and perhaps more important motivation for this seminar is to also showcase some of the research that I've been peripherally involved with by some early career researchers over the last 5 years or so, and in particular there from top to bottom, Kate Winter, Afiz Jeffrey and Guy Paxman, who have done a lot of the work that I'll probably talk about in the course of today. So this is kind of the motivation for why I want to do it. And what are we kind of interested in kind of, there's a whole range of things we want to kind of understand about the kind of what we might call the Foundation Ice Stream Academy Glacier Patuxent Ice Stream kind of catchment. And the reason I kind of referred to it as a complex in the title is because it's really a complex of 3 outlet glaciers, and then also kind of, if you count Support Force Glacier in there as well, maybe 4. And it comprises, as you can see from on that figure on the right hand side, if you can see the 3 red dots, which I think are other things related to this figure, but you can see there's an area with FIS, AG and SFG kind of in the top left quadrant there. And that's a ice velocity map showing South Pole in the center of it, and then the ice flow, particularly around the kind of eastern side of the Filchan ice shelf in the Whittlesea sector of Antarctica. And the kind of what I'm referring to is the kind of Foundation Ice Stream, Academy Glacier, Patuxent Ice Stream kind of complex is this kind of area annotated FIS and AG in that figure. And we tend to think of it, Foundation, it's traditionally as kind of one system, but it's actually certainly 2, where Academy Glacier and Foundation Ice Stream are very, very distinct and very separate. And we'll come on to that in the next slide. But in addition, there's this kind of separation of also of the Foundation Ice Stream, which actually has not just the kind of it has 2 tributaries, one which is the kind of the Foundation Trough, but the other one is the kind of Academy Patuxent Ice Stream, which is the area which is actually annotated Foundation Ice Stream, or FIS there in that one. So a complex set of kind of three main tributaries that combine to form the kind of joint Foundation Academy trunk. And what's interesting about it is that it brings in and composes ice that comes in both from West Antarctica through the kind of Foundation Ice Stream kind of side of things, but also the Academy Glacier side brings in ice from East Antarctica. And there's a definite and distinctive kind of partition in that kind of area. So I'm hoping you can see the mouse that I've got there. And you can see here, we've got kind of, as Academy Glacier comes in, we've got ice coming in from East Antarctica, and the Foundation Ice Stream side is bringing in ice from West Antarctica, with that kind of separation as well of the subglacial hydrological systems as well. Now, Foundation is interesting, or Foundation Academy is interesting as well, because the trunk is quite narrow. It's about 40 kilometers wide. It's got a relatively fast flow, but not kind of up to the speeds of maybe Pine Island type situation, somewhere around 600 meters per year, kind of maximum speed. But the actual bed of the glacier rests about 2 kilometers below sea level. So it's very, very deep trough that the outlet of Foundation and Academy flow through. But it has a kind of broader system, which, you know, the ice flow extends much further inland up to the kind of onset zone, you might think, maybe where flow starts to initiate around 25 meters per year or something like that. There's onset flow, which is quite close to South Pole, both for the kind of Foundation limbs and for the Academy Glacier kind of limbs. The figure on the bottom left, which you can see here, and for those who get the bearings, the kind of Foundation ice stream is there. If you can see my mouse, hopefully you can. And you can see there that there is this kind of coloration of this kind of broad grounding zone in kind of at least a kind of couple of kilometers wide in that kind of area that's there. And this is because the grounding line is not kind of closely defined as just being a static point. There's actually some migration of the grounding zone. The position depends very much on the tides. As we know, the Whittlesea sector, West Antarctica and East Antarctica, then there's quite significant tidal fluctuations of the ice shelf in that area, and that causes the grounding line to migrate. And importantly, as kind of mapped out by initially kind of Ben Smith and Helen Fricker, the Foundation and Academy systems have very active subglacial hydrological system with evidence from the ice surface elevation change in localized pockets, and I'll show that slide a little bit later, of kind of water moving through this system. It's a very active subglacial hydrological system, assuming that those things that we're seeing as anomalies in ice surface elevation are actually subglacial lakes, of course, and subglacial hydrology and other things. Okay, so moving on to some of the details, and I've talked about some of these kind of aspects already. So this is the kind of visualization of that. You can see this nice map was produced by Guy Paxman that came out in G Cubed in 2019, so just last year even. And Guy took a data set, which we'll talk about a little bit later, the polar gap data set, combined it with all the other existing radioactive sounding measurements of ice thickness to produce this new bed elevation map of this region. And this predates kind of bed machine coming out, and there's no kind of mass conservation aspects to this one, although we'll come to the bed machine map a little bit later. You can see the kind of geography of the Foundation Ice Stream and Academy Glacier system. We can see we've got the Foundation and Academy kind of trunk. You can see the deep incised trough that's there, up to kind of 2 kilometers below sea level. And we've got the kind of the two limbs of Foundation come out towards Steel Mountains, as marked on that map, and one being a kind of narrower limb in the Foundation ice stream kind of trough, which extends further inland. And then also in this kind of broad trunk, this kind of broad tributary, there's still below sea level, this area of the Patuxent ice stream, which is a broad kind of onset zone of the kind of Foundation ice stream system. And there's some interesting things in that kind of area, which we'll touch upon a little bit later. But the big kind of story about this kind of paper and the other polar gap work that Tom Jordan published on is the kind of discovery of this Pensacola Pole Basin. Well, not the discovery of it, but the improved refinement of this Pensacola Pole Basin. We've known about it for a while from the 1970s surveys onwards, but this is the first time that there'd been a kind of a targeted survey to kind of identify this, and how this Pensacola Pole Basin, which extends further inland, also refines its geomorphology and its kind of elevation below sea level, and confirms that throughout large parts of it. But also Guy's paper, and I won't have time to touch upon it today, but goes into some of the kind of using the potential field data, the gravity and the magnetics work to understand the kind of the sedimentary basin that lies in there and the kind of subglacial geology of this region. And as you can see, the kind of the Pensacola Pole Basin and that kind of deep basin kind of to the grid north of Steel Mountains, you can see there, this whole area is surrounded by a lot of highlands, including kind of the continuation of the Transantarctic Mountains, but also the kind of the polar gap subglacial highlands named after the Polar Gap Survey, the recovery subglacial highlands, etc., etc. So we've got this kind of area there where we've got this kind of large basins well below sea level, which is surrounded by these large subglacial highlands, which have been kind of refined by some of these recent surveys. And the figures on the right-hand side come from Hafiz Jeffries, Nick Chacom's paper in 2018, which looked at some of the active hydrology and its interaction with the ocean as well. And you can see the top figure is ice velocity, and we can see the Academy Glacier, the upstream foundation, identified on that. And you can see the kind of narrow, 30 to 40 kilometre wide kind of trunk, an outlet into the Filchner ice shelf and the Thiel Trough, of course. And you can probably just make out there that you've got the Academy Glacier flow coming in here, the foundation flow coming in here, and you've got a kind of separation between them. And actually those kind of two flow components remain very distinct and separate as they flow into the main trunk. And as you can see there, with the kind of modelled hydrology from the bed DEM data that we had available at the time, you can see that we have water coming in from West Antarctica through the foundation kind of catchment, and also water coming in from East Antarctica from the Academy Glacier type catchment. You can see that in the trunk, according to this kind of flow modelling work, that that flow of the subglacial water is partitioned and doesn't mix underneath the ice stream trunk. So we've effectively got two kind of ice streams flowing side by side in the trunk at this point. So kind of very interesting kind of geographical kind of aspects of some of this, which have been picked up in some of the recent work. Okay, so before I kind of want to go on, I've done the kind of geography over the last couple of slides. Before I go into some of the new modern work, what I want to do is kind of, now you know where it is and you know what it's made of, I guess what I want to do is kind of give you some kind of history as well about when kind of the Foundation Ice Stream Academy Glacier complex was kind of discovered and first mapped, and some of the background behind it, and also some kind of long-standing Newcastle University connections to this glaciological catchment, I guess. So the first thing is that it was kind of identified and mapped by the United States Geological Survey from both field surveys and aerial photography work in 1956, 1966, lots of exciting, interesting nun-attacks with some great geology I hear around there as well. And actually, Foundation, very simply, was named after the National Science Foundation in America, and Academy Glacier was named after the National Academy of Sciences. So very logical kind of names there. And there was some early, I should say, in international geophysical year work, so 1957, 1959, by John Byrne and Ed Thiel in the area. I must have a look at the exact plots of where their traverses were, but I know there was certainly, they worked very close to that area, if not on the glaciers themselves. They certainly worked in the offshore on the ice shelf surrounding that. But what's interesting for me in particular, and the reason I've put this photograph of the Trans-Antarctic expedition, it's not quite the most famous photograph of that kind of collapse of the snowcats into the crevasse or into the snow pits. But I like that picture because it kind of shows them getting it out and rescuing it rather than actually going in and scratching their heads wondering what to do about it. But what's interesting about that is it was traversed the kind of upper parts of, I guess, the Port Force Glacier and also Academy Glacier were traversed by the Commonwealth Trans-Antarctic Expedition, the Hillary and Fuchs expedition of 1955 and 1958. And I must plug the kind of Newcastle connection here in that one of our lecturers at the time, a person called Hal Lister, who had actually also been on the British North Greenland expedition in the early 50s, was part of that expedition. I have a hunch, and I'd be interested to see if anybody can counter this and see if anybody knows of anybody earlier, but I think he was the first person to perhaps overwinter on the Greenland and Antarctic ice sheets. So I'm going to put that claim out. If somebody disagrees with that and has contrary evidence, let me know. But that's a picture of Hal there on the right-hand side, I think taken from Greenland, doing some glaciological measurements. And certainly there's a whole other lecture just on Hal and some of his expeditions works in Greenland and on the Trans-Antarctic expedition. But I believe there's some seismic data and gravity data also acquired with the Trans-Antarctic, so interesting to have a look at some of that. So, long tradition of that kind of work done, both in Newcastle and also involvement in this kind of area of the ice sheet. And as we move on further in time to kind of the 1970s and a little bit onwards into the kind of 1990s, there was the big, obviously, SPRI, NSF, TUD, aerogeophysical surveys in the 1970s, which did a very extensive job of kind of characterizing this system. And if you look on the left-hand side here, you can see a plot from David Drury's paper in Polar Record in 1980, showing the kind of survey area of the SPRI work that was done at the South Pole, so covering kind of foundation, parts of support force, and also Academy Glacier in the kind of latter half of the 1970s. It's a kind of funny map because the Filcher-Ronny ice shelf is off to the kind of northwest of it, and the Ross ice shelf is over to the other side. But you can see it was quite an extensive and detailed data set. And there wasn't this particular, I haven't ever found a particular specific paper that worked that data set up in a specific way dedicated towards the Foundation and Academy. But what they did do was they put it into a kind of overarching picture and Drury paper in Nature in 1981. And you can see that figure there on the bottom is a kind of map of ice topography. You can see this is the Disciple Coast to get your bearings. This is the Disciple Coast ice streams here in the kind of grey colours. This is looking over towards Thwaites and Pine Island Glacier. And then here you can see where I've drawn the box very conveniently. You've got the kind of classic shape of the Foundation and Academy trunk in here. You've got the Foundation stretching back into the interior of West Antarctica here. Then you've got Academy, which stretches into the interior of East Antarctica. So they've actually mapped out this kind of ice stream location, I think it says in the key there on the bottom left. So from that work from the early 80s, they had the kind of general broad sense of Foundation and Academy at that point in time. And later on, there was some work, some pioneering kind of glaciological work done by Avi in the 1990s, and that was a mixture of both aerogeophysical research and ground-based investigations, so radioecho sounding, seismics. There was some accumulation measurements made and some other work, and that was the kind of first kind of targeted survey of some of those areas, looking right across from Institute ice stream across to the Foundation ice stream as well, and got profiles going back up the ice stream trunk, so aligned with the glaciology, and that can be quite a significant thing as well. But also, as you can see here, there was on this map on the top right, the survey extended from the kind of Foundation down in the bottom part, a kind of 700, I guess, kilometers along this line, right up to kind of Filcher Station area in the right at the kind of edge of the ice shelf. So taking seismic measurements to kind of get a flow line characterized very neatly. And that work was published mainly by work by Astrid Lambrecht in 1999 and 2007. So just wanted to kind of credit those kind of early surveys as part of this kind of historical insight into the Foundation Academy glacier systems. Okay, so why should we care about kind of Foundation Ice Stream and Academy Glacier? Well, the big kind of major issues, of course, is that the catchment as a whole, you know, it goes right into the interior of East Antarctica. You can see it there in the middle picture, in the red outline, which kind of outlines the Academy and the Foundation systems. And combined, the two together are about kind of 3 meters of global sea level equivalent is locked up in there, were it all to melt. And of course, that's not probably going to happen, but there is a potential, obviously, for parts of East Antarctica, in the same way that not quite in the same way, but similar to the way that we understand for West Antarctica for marine ice sheet instability processes. You might see deep subglacial basins like Aurora subglacial basin, Wilkes subglacial basin, where they have the potential for marine ice sheet instability to result because they've got these kind of weak underbellies as well. And that's kind of been postulated for parts of East Antarctica were it to start to significantly kind of deglaciate. And potentially the kind of Academy and Foundation catchments have a similar kind of thing set up in that they also have these large areas, which are, as I said, from kind of Guy Paxman's map earlier on in this talk, that there is the potential for that kind of marine ice sheet instability to also kick in to some extent as well, because they have these marine basins which are present below sea level. So, and particularly I'm thinking about the kind of Pensacola Pole Basin, which stretches inland through the Academy and kind of support force systems up towards South Pole. Another kind of justification that's been important, and maybe less so now because we're getting to a point where we have got data over there, although it's not necessarily oriented in the right directions, or in the right way, because it was used to collect data for other purposes. We've got good radioecho sounding data in place. We've got much better coverage than we did before the Polar Gap Survey. In particular, basal topography was very poorly constrained in this area in BedMap 2. There was only the kind of 1970 surveys. So characterising that system is quite key. Obviously now we have the bed machine product, which came out at the kind of end of last year into the start of this year. And you can see I've just kind of put a red box around that area to show you where the Pensacola Pole Basin extends. You can see it's below sea level, and the kind of average, I think, from Guy's papers, we'll find out a little bit later, about 500 meters below sea level is an average across the whole thing. But not all of it, if it deglaciated, would be below sea level because of isostatic adjustment. But as you can see from this kind of figure here in the bottom right from Matthew Mulham's paper, you can see that we have much better characterization. The colored lines are new data acquired since BedMap 2. As you can see, it's still sparse in places, and it's oriented in ways which are not necessarily conducive for kind of glaciological application. The other thing that's very interesting, and I think has been overlooked a little bit to some extent, is that both the Foundation Ice Stream trunk and the Patuxent Ice Stream, so that kind of tributary limb of Foundation itself, have very low basal shear stresses. And you can see there from Ian Yockin's kind of inversion of the area from the kind of BedMap data set, I guess, in 2006. You can see those blue coloured areas showing these areas of low basal shear stress. And normally those kind of dark blue colours that you can certainly see underneath the Foundation trough are kind of similar to what you might invert for kind of cycle coast type areas. So evidence of weak marine sediments has obviously been proven there. Is that the case also for the Foundation Ice Stream trunk, and also for the parts potentially of the Patuxent Ice Stream? Or are there other reasons why that might be kind of smooth, bedded, and have a low basal shear stress in there? Is there other geological controls on that are not related to kind of the deposition of marine sediments? The other few things that are important about kind of Foundation Academy as well is that, as you can see from the, well, I can't see necessarily from the figure on the left-hand side, I put it in as a kind of aid memoir to me, more than anything else, but this is work by Sasha Carter and others in G Cubed in 2007, looking at and identifying subglacial hydrology in the upper parts of this catchment. So beneath the South Pole, there are subglacial lakes, South Pole Lake, but also others. And there's lakes that have not only been identified in the upper catchment, but there's also evidence from the kind of IceSat record of this kind of connected hydrological system all the way through. So subglacial hydrology is interesting. We should find out more about that. It's very active. The other factor as well is, of course, although it might not be doing terribly much at the moment, the Foundation Academy system has shown significant evidence of change in the past. So there's 800 meters of vertical elevation change from the last glacial maximum, as shown by Keir Nichols' really nice paper that came out in the cryosphere last year in 2019, from new cosmogenic dates or reanalysis of it, of existing samples that are in there as well. So using 14C isotope to constrain that kind of thinning rate and the amount of thinning since the LGM. So there's been big glaciological change in that area. The other thing that suggests kind of glaciological change since the last glacial maximum type period is the evidence from Rob Bingham's paper in Journal of Geophysical Research in 2007, which used the old 1970 SPRI data and some of the data from University of Texas, looking at disruption of end glacial layers in the upper catchment of Support Force, Ice Stream, and Academy Glacier to infer enhanced flow right up below and beyond South Pole in recent times. So buckling of those layers, the kind of disrupted stratigraphy of the ice sheet stretches inland, and that can quite often be diagnostic of, if not rapid flow, then certainly enhanced flow over kind of 25 meters per year or so. So the idea is that maybe the catchment was more extensive, or that the kind of catchment migrated through time. Well, where are we in kind of the current status? Is this kind of potential for glaciological change? Well, it's been relatively stable, I think, Foundation Academy Glacier, as far as we understand it, and as we think about it in the last kind of 13, 40 years, although there is evidence from, I think, this map of mass flux from kind of from 2017 or 1979 to 2017 of a kind of slightly larger kind of negative in the red colors kind of mass flux and in negative terms of from the kind of catchment in that area. And of course, we're starting to potentially see parts of East Antarctica being a major participant in the overall ice loss of Antarctica. And okay, so it's not definitely doing something. It's got a large ice shelf in front, of course, It's not necessarily going to be influenced by circumpolar deep water, but there is the potential for glaciological change. And I don't know how much to read into this, and I'm putting this up very cautiously, but I've taken the recent ISAT-2 paper here, and you can see this figure from that paper, which I love the color scheme on this. It highlights loads of things in terms of surface elevation change, in terms of not just the big changes, but also some of the kind of lower level things that are happening. And obviously, I like the kind of Willans and Cam changes that extend up to the divide there. Maybe we'll talk about those a little bit later. But also the key thing is that it's interesting for the kind of foundation and academy area, we are seeing some potential surface lowering over the 2003 to 2019 period. Nowhere of the rate of kind of Pine Island or Thwaites glaciers or the lower parts of the Antarctic Peninsula. It's kind of the order, I guess, of kind of looking at the colour scale, maybe tens, if not 10 centimetres per year. But it is showing a kind of spatially coherent pattern of change in that kind of area. And there are subglacial hydrological issues that may, influences that may impact that as well. So I'd be interested to speak to Ben and to Helen and people like that to find out more a little bit about whether that signal is fully real. I think it probably is, and what that means for this system. Cautiously kind of highlighting that. And of course, the big question is what might the future hold, and there have been individual studies, as like the figure in the bottom right, looking at kind of the foundation itself. There's also been work done by Pippa Whitehouse looking at the kind of the historical evolution of the foundation from the last glacial maximum in terms of its ice sheet retreat. But also we need to think about what might the future hold. And of course, there's lots of models. I've just taken a few to highlight these things here. Of course, there's the kind of Pollard and DeConto model with marine ice cliff instability in there, which is the kind of one on the left-hand side, and in particular D. If you look closely on that, you can see that certainly some of their model runs certainly showed kind of deglaciation of the Pensacola Pole Basin as one of the kind of weaker underbellies of East Antarctica. But obviously was based on, I guess, BedMap 2, I think that's probably correct, and didn't have the better constraints that we have on particularly the question of whether topographic lip might exist somewhere between the kind of Academy glacier and where it joins onto the kind of foundation trunk. Some of the details of that, and obviously the resolution of the modelling, might not address some of those issues. So is that really likely? Is that kind of something that may happen in future, or is it a product of the model that maybe with better data we can kind of reduce that uncertainty relating to the potential kind of couple of meters of sea level change potential in that kind of basin? And of course, I'd just like to acknowledge as well Andy Wright's work that was done in the cryosphere in 2014, which looked at the whole kind of Whittlesea system and kind of looked at what kind of might evolve with all of those systems as we go forward in time. So I think we're still a little bit unsure about some of where the modelling work is kind of pointing to in terms of specifically foundation. I do wonder if I'm not aware of a few things that the FIS project, the Filton Ice Shelf project, for example, might be ongoing, and I'd be interested to hear more about that and maybe update this slide as we go forward. But what I want to do today is really think about kind of the new RES data, radio echo sounding data that's been acquired, in particular the polar gap data, but I'll also talk about some of the kind of Croesus Operation IceBridge data in a slide or two as well. But this one has been a kind of game changer for me, and I'm very grateful in particular to Fausto Fraccioli of British Antarctic Survey and Tom Jordan and Hugh Cole for sharing these data and processing these data for me, as well as kind of ESA for sharing it with me, but also for ESA for kind of, and Renee Bosberg and Kenny Matsuoka for kind of driving this forward to get this these data collected for obviously a reason which was not necessarily primarily glaciological, because it was designed to kind of fill in the kind of the gap in the geoid around the kind of the polar regions, as you can see from the kind of orientation of the flight lines spreading out from South Pole. But obviously there were some glaciological targets in terms of as you can see from that map in the centre, the kind of recovery lakes in the top, and also some kind of nice flight lines which were quite opportune, both kind of over kind of Academy Glacier itself, but also some around kind of Thiel Mountains and the kind of hinterlands of kind of parts of West Antarctica, and what the kind of has been kind of coined the kind of bottleneck interaction zone between the East and West Antarctic ice sheet. And we'll talk about Kate Winter's work in that in a slide or two. But these data are obviously acquired primarily for gravity work, but obviously there's radio echo sounding on board the geophysical platform, and thankfully I jokingly commented to Fausto in a bar at the SCAR conference a couple of years ago, could I please have some data from you, some old historical data? And he said, yes, of course, you have any data you want, Neil, you just need to ask. I said, well, can I have your new polar gap data? And he hesitated for a moment, and he said, yes, you can. Let's work together on this. So we did some work on kind of looking at some of the subset of these polar gap data for Kate Winter's work, and obviously for Guy Paxman's work as well, which I'll talk about. Okay, but we've got this new radio echo sounding data which kind of fills that polar gap, not just in terms of gravity data, but in terms of a lot of ice thickness measurements as well. And the platform that used for collecting these data is the British Antarctic Survey aerogeophysical platform. There's Tom Jordan. I saw him smiling at me, trying to put me off as he joined the Zoom call earlier tonight. And you can see there he is on the plane in terms of inside the Twin Otter, monitoring all the equipment and with the gravity, the magnetics, and the radio echo sounding on the Twin Otter. And using not the kind of an updated version of, I think it was the first field season for the Passin 2 radio echo sounding system that VAS operate. And that has potential, I think, to kind of do 3D kind of swath bathymetry type work, but I think that we haven't got that for polar gap. The design isn't there for that, so we're still on the kind of old two-dimensional kind of profiles across the ice sheet. But there's lots we can do from that. Okay, so one thing I kind of want to emphasize a huge amount here is that my role in this kind of presentation is simply just a storyteller. Other people have written the story, and in particular, as I said earlier, Kate, Afiz and Guy had these fantastic papers, along with other great papers that I've been involved with in small ways that these three authors have led. And over the last 5 years, I've been very fortunate to work with some fantastic early career researchers who have really done some fantastic kind of groundbreaking work. Kate did a very short kind of postdoc with me, which is almost a kind of informal postdoc where it was a very, very small amount of money, but we worked on the polar gap data in that kind of bottleneck zone between East and West Antarctica. Afiz was a PhD student with Martin Seagate at Imperial College London. Now he's kind of the external supervisor on that, and he did some great work looking at the kind of the hydrology and the interaction of the subglacial hydrology of Foundation and the offshore kind of ice ocean interactions. And then also Guy's work on the kind of more geological and tectonic kind of history of West Antarctica, again in this case using the polar gap data, where Afiz used mainly Operation IceBridge. But what I want to do is kind of showcase their work over the next kind of 3 or 4 slides before we kind of go on to what might be things we might want to talk about in terms of the future work. Okay, so first one here is Kate's work, and this was kind of something that I've been interested in before the polar gap data, was kind of what happened between kind of the Cyprus coast and the Weddell Sea sector, so between the Ross and the Weddell Sea sectors, of mainly West Antarctica, because at that time it was the data that were available, but obviously the polar gap flights that became available had this kind of radial pattern out from South Pole, were perfect for kind of characterizing the kind of ice divide between the Ross Sea sector and the Weddell Sea sector of West Antarctica. And this, what was coined a few years ago as being the kind of bottleneck zone where the East Antarctic and West Antarctic ice sheet collapsed. I believe that Terry Hughes proposed that this bottleneck zone was a potential area of instability, because if West Antarctica deglaciated, then East Antarctica might then collapse through this kind of bottleneck zone. And what was interesting was looking at this kind of the polar gap data, it was clear to us that there were a kind of series of major troughs, 2 of which cut right through the kind of subglacial mountain range between the Weddell and the Ross Sea sectors, the Foundation Trough and the Patuxent Trough are kind of annotated there. We also tried to look for a kind of link through of the offset rift basin, which was kind of discovered by Michael Studinger and Robin Bell and some of the Texas team, I think. And as you can see there, we couldn't find a definite connection right through, but certainly the Foundation Trough and the Patuxent Trough are there. And at the same time, as well, some of the kind of new mapping, I think, from Jeremy Mugino's kind of work from the updated ice surface elevation was getting better towards the interior of the ice sheet. We're able to identify that these kind of deep troughs, as you can see there from the color scale on, or the vertical scale on A, kind of a couple of kilometers kind of relief, controlled some of the kind of onset flow of ice in that area, both in the kind of upper parts of the South Pole Coast catchment, but also in the upper parts of the Foundation and Patuxent ice stream systems. And actually these troughs connect the deep interior of Antarctica, the West Antarctica and parts of East Antarctica, to the kind of margins of the kind of Foundation trunk and then also the South Pole Coast ice streams. What's interesting, of course, is that the orientation of these troughs is kind of perpendicular to the ice divide. So we can see here on this figure in the middle in the colour, you can see the ice divide and the dashed line, the Foundation trough and the Patuxent trough in the kind of blue and red arrows, either cutting right through that, perpendicular to the kind of ice divide. What Kate postulated in this paper was that these troughs actually limited the potential downdraw of East Antarctica through the bottleneck zone because of their orientation and the orientation of the high subglacial topography in this area. But there was a potential, either as a result of kind of large-scale kind of oceanographic forcing of or internal dynamical change, perhaps in the Whillans and the Cam ice streams, that these could play a role in kind of ice divide evolution for West Antarctica potentially. So that was something that we kind of speculated on in the paper. Kate did a fantastic job of that. As well as doing some really fantastic, exceptional kind of scientific work, Kate's also really good at visualizations, as you can see on the left-hand side. Now, I know there's a really good one for Antarctic coming in the next few months, I think, probably, hopefully. So I won't put the cat in the bag on that one. But what I thought was really interesting, and no apologies for the pun on this at the top of this, you can see that echoes very much of Kate's kind of visualizations on the left-hand side, with this kind of lovely figure from Rose et al.'s Journal of Glaciology paper in 1979, looking at the kind of ice flow of the South Pole Coast ice streams. And we actually rediscovered this figure on the right after Kate had done this lovely kind of 3D visualization there on the left. So, but you can see there's nice echoes with the kind of potential for ice flow to be related to subglacial topography in some of these ways. And you can see even the Whitmore Mountains, which are part of this survey area, annotated up in the top of that. So yeah, a lot to be said for great visualizations of scientific data as well. And I think that's a fantastic example. Okay, so moving on a little bit. So that was kind of looking, that last kind of slide was looking more at the kind of Foundation ice stream system and the Patuxent ice stream. Guy Paxman's paper in G Cubed, looking more in the kind of where the Academy and the support force glacier systems flow out from the kind of onset zone near to South Pole, outwards towards the margins of and into the Filtration ice shelf. And Guy did lots of potential field data analysis with gravity and magnetic film. I'm not going to show here, but what I will say is that Guy managed to, if you can see in the figure in B there, this is the rebounded topography for the Pensacola Pole Basin. So you can see that actually, if this area were to deglaciate, you could see that parts of the northern Pensacola Pole Basin would be below sea level if fully rebounded by isostatic adjustment. But if it did rebound from deglaciation, then the southern parts of the Pensacola Pole Basin would mainly be above sea level. So there wouldn't be this kind of deep marine basin in this kind of setting. And obviously it depends upon the rate of uplift and the timing and the nature of deglaciation and how much ice is there as the deglaciation occurs. But in this kind of model, you can see that there's only a very, very thin channel delineated by the kind of white dashed lines, which show this area which would remain below sea level, which extends far into the ice sheet. So it's not perhaps, although the Pensacola Pole Basin is on average 500 meters for isostatic adjustment, perhaps large parts of it would actually uplift above sea level. But nonetheless, there are still over-deepened troughs which extend some kind of 800 kilometers into the interior of Antarctica near to South Pole. So it's not totally out of the woods. The other thing that the guy's work did was obviously looked at the kind of the nature of the sediments that within this Pensacola Pole Basin, and suggested that any deformable marine sediment that might be there would be very thin, in the order of geological context of thin, less than 1 kilometer thick, but there may be the possibility for a thin drape of marine sediment on there. But it's unlikely looking at some of the geomorphology. It's quite a rough kind of surface, so that's questionable for that. So it doesn't, my kind of inkling towards this is that the Pensacola Pole Basin is perhaps not as a significant a marine basin, East Antarctic marine basin, as we might have once thought. But maybe that's open for debate. And just as well, just to say that very briefly, Guy looked also at the kind of relationship in that paper between kind of ice flow, which is the velocity map on the top. This is x to x prime. This is the profile which runs across here. This is ice surface elevation. You can see the high East Antarctic interior and the ice flow across the basin. It's interesting to note that, and obviously there's lots of factors which drive ice flow, but you can see that large parts of the kind of deep subglacial bed in the deepest parts of the Pensacola Pole Basin, there's not a coincident kind of high rate of ice flow through that basin. The rapid ice flow of Academy Glacier is actually offset in some of the kind of intermediate level parts of the basin. So there's some interesting stuff to be done on that kind of relationship there between bed topography, ice surface, and the ice flow. Okay, and the other thing I wanted to just highlight, of course, was Hafiz Jeffrey's work on looking at the kind of ice shelf channels being generated by subglacial hydrological flow. There's loads in this kind of figure here, and I don't expect you to take it to digest it here. But the main story that we have is that water that's kind of discharging, the subglacial flow that's discharging from the kind of Academy Glacier and the Foundation system. We saw they were kind of partitioned at the start of this talk. What's interesting is that certainly the water from Academy Glacier, it seems to come in at 90 degrees to the kind of Foundation trunk and Academy trunk, and then it gets diverted at 90 degrees by a series of linear features along the subglacial bed, which to our interpretation seem to be kind of hard rock landforms rather than soft sediment landforms. We have a few kind of radio echo sounding lines across the trunk. I know the FIS survey have a lot more detailed available data sets now, so it'll be interesting to find out from them whether these features that we inferred from a couple of radio echo sounding lines, in particular I to K on that map there, which are across ice flow, these kind of ridges that we've got on the bed, and they're quite large, a couple hundred meters high, and they seem to have high reflectivity associated with these, the sides of these, or the peaks of these kind of features. And what we suggested was the water was being diverted along these features, then reaching the grounding line, rising up, and then generating these ice shelf channels. So you can see here, this cartoon on the top right is looking into the interior of the ice sheet. You can see ice flow is out towards you. You can see these kind of large grey kind of basal topographic features, and the water is coming from kind of Academy on one side, Foundation on the other, and it's being channeled along these kind of ridges, reaching the grounding line, and then that water is rising up in these kind of plumes, probably in training kind of ocean water as well, and then generating these kind of classic ice shelf channels at the bed of the ice shelf. And you can see here the kind of nice cartoon schematic that I think from Anne LeBroc's paper in 2013 with the Eiffel Tower, and I think London Tower Bridge is there, and you can see these kind of ice shelf channels. We think these are being initiated at certainly Foundation Academy by this water which is being routed along the bed of the ice stream trunk by this subglacial hard bed landforms, we think, rather than anything else. But in between those hard bed landforms, we think there's a drape, probably of marine sediment in the intervening kind of portions between these ridges. So, okay, so that was a kind of very brief kind of overview of those work, and I'd encourage you to go away and have a look at all three of those papers, all of which are open access, so you've got no excuse to go away and have a look at those. They're worth having a look at in more detail, and great work done by all three of those kind of early career researchers. I don't think I mentioned earlier, of course, that Guy was a PhD student at Durham University with led by Mike Bentley and Stuart Jameson and myself as an external PhD supervisor as well. And Fausto Fiocchioli was involved too, so, and lots of other people from various teams, including Polar Gap. Okay, so what yet don't we know is the kind of next question, and maybe some of these might be starting to be answered perhaps by some of the work done by the FIS teams, so British Antarctic Survey and ARVI. I've been working in the kind of grounding line areas around the Whittlesea for the last 5 years or so, and they've got some great radio echo sounding data around these slide might be being answered already. I think, you know, we need to have a better appreciation of kind of the grounding zone in this area. I said before, it was kind of a relatively wide grounding zone, perhaps possibly with kind of migration of what you might think is the grounding line, with tidal signatures, and this was certainly an interesting one that came up from, you can see here on the lower image, we've got the radio echo sounding data here. We've got the kind of trunk of Foundation, or well, this would probably be Academy side actually, of the trunk. You can see this flat bed well below sea level, rising up to the ice shelf. The different grounding lines that are available are kind of 20 kilometers apart. The INSAR one puts it somewhere about here. The more kind of surface slope one puts it here. The reflectivity analysis of the radio echo sounding data from Tom M. Jordan from Bristol, so Stanford, puts it somewhere in the middle. So interesting kind of uncertainty about that, and maybe some of the new radio echo sounding data can fill it in. One question that's also arisen from that work by FEES is also the fact that the Foundation is actually not very far above flotation, right? So only kind of 25 meters or so above flotation for kind of 50 kilometers inland. So if you have even modest thinning of kind of the Foundation ice stream trunk, then you could have flotation of the trunk of an Academy as well. And the big question is, are these marine sediments that are draped on here? This is very flat, relatively bright, but not that bright kind of bed stretching back into the interior. It's 2 kilometers below sea level. The inversion data set suggests a kind of very low basal shear stress in this area. It'd be good to get some more constraints on whether that's the case or not. Okay, the other things that we don't yet know about Foundation Academy, well, this is the kind of map I promised earlier. This is the Ben Smith and Helen Fricker and I think Ted Scambos kind of product from 2009 in Journal of Glaciology, where they looked at this across Antarctica at kind of active subglacial lakes from ice surface elevation. And they actually, figure 2 of that paper actually had the support force on Academy Glacier, because there was some really significant kind of anomalies in the ice surface elevation here, which suggested that there was active subglacial hydrological processes going on. Particularly here, I think C to D and A to B are these graphs here. So 6 meters of elevation change over maybe 3 or 4 years in the course of these surveys, and filling of these kind of systems. Are these active subglacial lakes or something else? We've had some work. One of master's students, Lauren Darby, who's just submitted a master's thesis at Newcastle recently, has been looking at the reflectivity of these lakes, because some of the polar gap flight lines went over these. Are these active subglacial lakes or something else? Well, we'll maybe find out sometime soon. The question as well is there potential for any hydrological switching or even ice flow switching with the support force glacier? What influence does hydrology have on ice flow onset? I said at the start from Chateau Carter's paper that there was water at the head of these ice streams, at the top of Academy in particular. This is the Seagate and Bamba map from 2000, looking at kind of, the white dots, the white circles are subglacial lakes beneath the South Pole. This is the balance velocities before we had the satellite-derived velocities. Right at the head of Academy, do they influence the kind of onset of ice stream? And in particular, what role does some of the high geothermal heat flux, and I'm sorry to Tom Jordan of Bass for neglecting to put his paper in earlier. I sneaked this in after I realised I'd forgotten it, that there might be high geothermal heat flux in parts of the catchment, and that might have an influence on some of the flow. So we need to kind of get some constraints on this. And then also, this kind of the ISAT data, ISAT2 data set, recent paper, kind of also shows the importance of this, particularly since we know how near to flotation the trunk of Foundation is from FEES's work. Is this system vulnerable? My inclination is that the kind of Pensacola Pole Basin may not be as vulnerable as we think, partly because of the kind of nature of the kind of the relatively low kind of or relatively high elevation of the bed in it, and the influence of isostatic uplift. Also, the configuration of the kind of way the ice flow of the Academy joins the kind of Foundation trunk, and whether there's any kind of bedrock lips there that might limit marine ice sheet instability potential. And of course, these systems are very different in this catchment in the Whittlesea sector than maybe parts of Pie Island and Thwaites Glacier, because they don't have the kind of, they do have the large ice shelf in front of them, which creates buttressing. They may not be so vulnerable to kind of marine ice sheet instability as other parts of East Antarctica in particular. The other thing I'd love to know more about, and certainly I think will be the focus of Glacial radiostratigraphy project, the Architecture project, and program. If you don't know about it, go away and have a look at that link. and it'd be interesting to have a look at some of the internal layers and the basal structures around this catchment going forward. And I think we've got a PhD student coming on board to do some of that work in Newcastle at the end of this year, I hope. And finally, you know, and the reason for that is to understand kind of basal processes, but also to understand the kind of history of ice flow across this catchment to right up to South Pole and beyond, perhaps. Okay, so there's lots of things that we still don't know about Foundation and Academy Patuxent Complex, but there are lots and lots of kind of future and archive research opportunities that exist. For example, looking at subglacial topography, the hydrology, particularly the active subglacial lakes, the basal sediments, and also that kind of radiostratigraphy. So all these things I've talked about in the last couple of slides. I think there's a potential to use existing RES data, radioactive data. I think we've only scraped the surface with lots of those data sets across Antarctica. And I think in particular Polar Gap and the surveys nearby, and even back to the old kind of SPRI, NSF, TUD data sets as well can be looked at, I think, to kind of investigate this a bit more. I think there's also a need for kind of new field work and numerical modelling work to be done in this area. And as I said, some of it may be being done by the kind of FIS project that's certainly around the kind of lower parts of Academy and Foundation. But it was interesting, it was really caught my eye from the bed machine paper that to improve the mapping of fast flow regions, we recommend flight tracks perpendicular to the flow direction to maximise constraint ice flux and support post glaciers. So I think we really do as a community need to kind of push to kind of get this done. And it's going to be difficult in some respects because a lot of the funders will say, well, this has been surveyed already. But as I said already, a lot of the survey flights are not oriented well, for example, to constrain ice flux, but also for things like understanding the englacial stratigraphy as well. We need to have lines which are oriented in a manner which is appropriate and informative for glaciological questions as well. So it's not just a case of seeing that there's some flight lines in that area and that's enough to do. So we need to think about that carefully and plan how we might do that. Okay, so this is just about my last slide. It's the kind of first holistic overview of the kind of Foundation Ice Stream-Academy Glacier Patuxent Complex. And if I get the chance, I'd love to write this up as a kind of large review type paper. Hopefully that would be useful for the community, and I'd like to get people involved if people are interested in doing that. We've got a much better kind of catchment geometry in terms of the bed elevation and topography. We're understanding a little bit more about how basal topography controls, or maybe not controls, ice flow, and also how it might route subglacial water beneath the trunk of the ice stream. I think we're only just getting to an understanding of how water might flow kind of through the upper parts of the catchment, and Christine Dow's been doing some work in that recently. And we also, I guess, need to know a little bit more about ice-ocean interactions. I think the kind of FIS project, for example, will kind of take up some of that, I think, in the next little bit. And it's interesting, we've got some really good insights from Guy Paxman's work, which I've only skimmed over today, looking at the kind of subglacial geology and geomorphology of the Pensacola Pole Basin and the implications of that for ice sheet stability going forward on the kind of longer multi-centennial kind of timescales and to millennial type timescales. I think we also need to, we've got some grounding zone characterization from some of the radioactive data, but we need a little bit more. Okay, that's it for me in terms of conclusions. There's still lots to do going forward, and I think we should be thinking about as a broad community to try and push forward and think about some of the kind of research areas that we might want to target on this in the next kind of 10 to 20 years or so. As I say, lots of things for all of us to do. I'd like to, just about before I kind of say what's going to be the talk next week, I'd like to thank a lot of the people. There's lots of people to thank in regards to, I won't do it all individually, but of course all the co-authors for the 3 papers that I've highlighted today, but of course all the people that have been involved in the logistics and the acquisition of the data. It's been a real pleasure to work with some of those data, but more particularly to work with the 3 early career researchers, Kate, Hafiz and Guy, over the last 5 years, and kind of found myself in this, as I say, in this kind of unique position where I was able to kind of pull all these different kind of into one kind of overview of the Foundation Academy Glacier. Thank you everybody for listening. I hope it's gone okay, and I will stop talking now and just put up one little advert. Erin Petit and the Tarzan team are going to come in May the 20th, so I guess that's next Wednesday, and talk about the strengths and weaknesses of the Eastern Thwaite ice shelf. Okay, thank you for listening.
Brilliant.